Hey everybody, here comes the second video of the day. It's called using the triangle inequality, which we saw in the previous video, and the converse of the Pythagorean theorem. Now remember, the triangle inequality, take the smallest two sides, add them together, it has to be bigger than the third side. The next thing is new, converse of the Pythagorean theorem, but it looks very much like the Pythagorean theorem. I want you to note one thing here. Notice that I put c squared on the left side every single time. This is a way that you can remember this theorem pretty easily. So here's three cases. First of all, check to see if it is a triangle. Add the two small sides and see that it's bigger than the third side. Scenario one, if c squared is equal to a squared plus b squared, that's a right triangle, kind of similar to what we've been working with. Scenario two, if c squared is greater than a squared plus b squared, then it's an obtuse triangle. Now notice, greater than, obtuse means has one angle greater than 90. That's the reason I put c squared on the left. Helps me to remember that greater than means obtuse. Third scenario, c squared is less than a squared plus b squared, means it's an acute triangle. Again, less than 90, acute triangle. Those will help you remember those three ideas from the converse of the Pythagorean theorem. Remember, converse is just switching the hypothesis and the conclusion around. So here's three examples I want to show you guys really quickly. Three potential sides of a triangle are 7, 12, and 16. Take the two small sides, add them together. 7 plus 12 is 19. 19 is bigger than 16. Therefore, it is a triangle. The triangle inequality is true. Next, let's check to see if it's a right, obtuse, or acute triangle. But the first thing is I have to check to see if it's a triangle first. So we're on to step number 2. So c squared, I need to see how it relates to a squared plus b squared. Okay, so what would I put in for c? Well, that's going to be the longest side, right? So 16 squared, 7 squared plus 12 squared, and just do some quick little multiplications here. I don't have my calculator. Hang on just a second. Alrighty, so we have 16 squared, and that's equals to 256. And then 7 squared plus 12 squared, I'm just going to figure that out and add them together. So 7 squared plus 12 squared equals 193. And 256 is greater than 193, isn't it? So that has to be obtuse triangle. Obtuse triangle. Okay, so now question number 2. 11, 18, 34. Take the two small, this is the triangle inequality. Take the two small sides, add them together. 11 plus 18 is 29. 29 is not bigger than 34. Not a triangle. We're not going to check to see if it's right, acute, or obtuse, if it's not even a triangle, because 29 is less than 34, and I wrote 24. Sorry about that. Less than 34. Okay, this two small sides has to be bigger than the third side. Final example, 3.8 plus 4.1. I'm taking the two small sides, I get 7.9. 7.9 is bigger than 5.2, so it is a triangle, so I proceed. C squared, a squared plus b squared, 5.2, 3.8 squared, plus 4.1 squared. Let me figure out what those things are. 5.2 squared, 27.04. 3.8 squared, I'm going to do it all together, all in my calculator, plus 4.1 squared, and I get 31.25. 31.25. This is less than that one, so it is an acute triangle, because this number, that's a 27, is less than 31.25. So again, equals right, greater is obtuse, less than is acute, but you have to put c squared on the left to see that, or it's going to flip the inequality symbol around. Thanks.